Hello viewers, good morning. Welcome to my YouTube channel, The Explicit Tutorials. Please endeavor to subscribe, like, share and comment. It is very, very important. Now this morning we'll be discussing physics, a topic called dimension. Now you have on the board about 12 examples of derived quantities on the board, and we are to deduce the dimension of each derived quantity. Now I shall be doing the crucial ones, the most important ones, and you take the minor one as your personal assignment. Now of course no one is minor. Yes, I can read your thought right now. No one is minor. What I mean is the most difficult ones, I shall be doing them, like Newton's universal law of gravity. I shall be doing it. Then EMF of a battery, then momentum, Young modulus and other examples. So let us start with let me take momentum. Now momentum means the product of mass and what? Velocity. Now therefore I can use this sign. Mass velocity is L t raised by minus 2. So momentum becomes what? MLT minus what? 2. Okay, no. Velocity is minus 1, sorry, minus 1. I thought I was reducing for force. Minus 1. Please, NB, take note of this. Take note. Take note. Momentum impulse momentum and impulse have the same dimension. Please take note of that. Momentum and impulse have the same dimension. That is for number 1. Then number 2, you have work done. Of course, the work done is a product of force and what? The distance, which is L. I can use L to denote what? Distance, since we are discussing dimension. Now the dimension of force is MLT minus 2 times what? L. Therefore, you have L here. L, it becomes L times L. You have L squared, then T minus what? 2. Please take note of that. The NB, work, torque, moments, Boyle's law have the same dimension. Please take note of that. Work, torque, moment and Boyle's law have the same dimension. Momentum and impulse have the same dimension. Then number three, let me take Young modulus. Young modulus is written as stress over strain. So solving completely, now be having FL over what? AE. F represents what? Force. You know that, okay? Young modulus. Force is MLT minus 2, then times L over. Now area means length times length. You now have length squared. Extension means what? Distance. So length times L. So you will permit me to do it like this. This will go into this. Alright. L will cancel out L. Then 1L will cancel out 1L from here. You now be having YM equals, this L is, the remaining 1L here is going up. It becomes ML minus 1. As soon as it goes up, you know dimension, we follow a particular trend. Dimension is usually in MLT, okay? The T does not come before the L, neither does the L come after the T, okay? It's usually like this: mass, length, and time. That is fundamental quantity, okay? Then you now have T minus what? 2. So this is the dimension of what? Young modulus. Another NB, another thing you should take note of here. Now, Young modulus, stress pressure have the same dimension, please. They have these three quantities, Young modulus, stress, pressure, they have the same dimension. All right, they have the same dimension. Now let me take this very one, number 8. Number 8. Now the law of gravity, Newton's universal law of gravity states that the force of attraction or repulsion between two masses m1, m2 is directly proportional to the product between the two masses and inversely proportional to the square of the distance that separates the two masses apart. All right. Now in doing so, I'm going to be cross multiplying. Now Newton used a constant g, not k, please. Now in that note becomes f arrow squared equals gm1 m2. To prevent this long expression, I can simply do it as m squared. All right, so I want to deduce for this Newton's constant over m squared over what? M squared. So this will go into this. I now have that g is equals f arrow squared over what? M squared. Hope you are following. Now the next step is to do this. Now force is mlt minus 2. The radius, distance, length, don't forget L over m squared. Now you have one m here and you have two masses, so one m will cancel out one m. What are you having left? One m. You are left with what? One m. As soon as the m goes up, it becomes what? It becomes m minus 1. You have t, you have L, you have L. So L times L is what? L squared. Then you are left with what? T minus 2. So please take note of, they brought this question. Now, if, for example, now somebody give you mx, ly, and tz. If they should ask you for the value of x, y, and z in any fundamental quantity, so long you've been able to get the final dimension, m, that is x, therefore, it means that x, in this sense, x is minus 1, y is 2, and z is what? Minus 2. That is how it is, all right? Which means that x here is 1, y is 1, then z is what? Minus 1. So that is how it is. Finally, let me deduce for EMF. The EMF of a battery means the work done in carrying a unit charge from a point of what? Infinity to a particular point, or to a considerable what? Point. Now, in doing that, you now have EMF equals W over what? Q. Right, now W over what? IT. From electricity, Q is what? IT. Therefore, this becomes work done. I deduced before as this, so you put it here, ml squared t minus 1. Then current, you have I, then calculator what? T. Don't forget, we're always using calculator T. As soon as this entity goes up, as soon as they go up, it becomes ml squared. Now, as soon as this t goes up, it becomes what? Minus 1. Therefore, you now have t minus what? 3. Okay? Then, you now have I minus what? 1. Therefore, the EMF of a battery dimension is equals what? ml squared t minus 3 and I minus what? 1. So this is the dimension of the EMF of a battery. So please, at this point, we'll call it a day. We'll call it a day. Of course, we've done for velocity, acceleration, force, and you can take the minor ones. I think I've done everything. Okay, the only one I did do is power. All right, I'll give you the formula. You take it home as your assignment. Now, power, the formula is work done over time. You know that power means the rate at which work is expended, or the rate at which work is done. Please, at this point, we'll call it a day. Thanks for watching. Please endeavor to subscribe, like, and share. Do have a wonderful day.